Good evening, everyone. My name is Françoise. I'm a data science technical lead at Shopify, and today I'm going to talk about what we do. So yeah, I said Shopify. We're not a music streaming company. We make commerce better for everyone. So what that means? So I think we're mostly known for our e-commerce platform, but you can use Shopify to sell online or in person. So whether you have a retail brick and mortar shop or you want to just sell online. But if you know Shopify already, you might be thinking, Françoise, what are you doing at a Python meetup? I thought you guys were doing just Ruby on Rails. And well, I mean, you're right. Shopify is one of the biggest and, well, largest and oldest Ruby on Rails application. And most of our engineering department uses it on a daily basis. Most of them, but not all of them. Because in data science and engineering, there's at least 150 people that use Python on a daily basis. Our whole data warehouse is powered by PySpark. And at PyCon, I will share the stage with my colleague, Chris Fournier, who's a data engineer at Shopify, and he will talk a bit more about that. So it's going to be probably, I hope, taped. So if you ever want to see his talk in a couple weeks when they are released. But today I'm going to talk more about the data science aspects. And it's not only about the tool, it's also about the community. So I personally, I'm one of the organizers of PyLadies Montreal. My colleague at Shopify, Catherine, is the organizer of PyLadies at Toronto. The sound guy tonight works with me, and also we host the Ottawa Python meetup, and even the guy who organized PyCon US in Montreal works at Shopify. So I think the people in this organization really care about the community, and we're really present, and so that's why we're sponsoring PyCon this year as well. Also, the library that Tristan talked about, Lifelines, was created by one of our coworkers. We use it internally, but it's also available externally. And we have a couple other libraries that are open source, and people also, in their free time, contribute to the libraries in Python. So I'm just going to give a quick overview of what we do on a daily basis as a data scientist, because data scientist is like a really broad term. So one of the things that we do is ETL, extract, transform, load. It's interesting because I think that in some companies you have ETLs engineers, and then the data scientists only touch the data once it's it's cleaned and it's available. While we are also responsible for the collection of the data and the cleaning. So in the ETL, we write PySpark jobs to transform the data with the business rules to clean it and to put it in the data front room, the front room of the database for everyone to use in the company. So I really like it because when I'm building my models, I know exactly how the data was cleaned, and I'm also empowered to go and look in the code because, like everyone, in our job, we know PySpark. So it's easy to know when something is wonky to deep dive and figure out what it is. As data scientists, we also do A/B experiments. So that is something that you do when you want to figure out is feature A better than feature B? So that can be done, say, before you release a new version of something, or you're just really curious and you want to know, should we put a little icon of a padlock so that people feel more secure during a checkout or not? So this is a screenshot of what it looked like. The whole backend is in Python. And I'm just showing the conversion rates here, but we also have the survival analysis one, and that uses Lifelines. We also have a team that is completely dedicated to creating recommender systems. So if you're a merchant and you need to find the best theme or the best apps, we will recommend them for you. So we do personalization of the product via recommender systems. So the data scientists are not just working, for the business, giving insights to the business, but we also are software developers. We create those products. Another example of a data product here would be product classification. So to make sure that so I would say that our data products internally really helps us create more value for other data products. So for instance, this is I have a t-shirt shop, so I just put it there. So let's say that you're selling t-shirts, but there's no way that Shopify would know that you're selling t-shirts because you haven't told us, right? We have to infer it from the title, from the description, from the image, and we do machine learning on that to create a data set to know all the products at Shopify, what kind of products they are. And based on that, then we can give better recommendations for the merchants themselves, either if that's recommendation of where to market their product, for instance, or how to price them. And I'm going to talk today mostly about exploratory data analysis, because that's a huge part of what I personally do these days. I'm now part of the systems research team, so we're a mixed method teams. I'm the only data scientist on that team. The others are UX researchers, and doing a lot of exploratory data analysis. But before I go on, I just want to check in with you. Are you comfortable on your chair? Because I'm 5'2", and when I sit on a conference chair like this, usually my feet don't really touch the ground. It's super uncomfortable. Like after 10 minutes, I'm all trying to get more comfortable. And I mean, like this would fit like most people, but not all people. Luckily, I spend at least 8 hours a day seated on a chair, but it looks more like this. This comes in 3 different sizes. I have the size small. My feet touch the ground. I can adjust, there's something like 12 different adjustments that you can make on a chair like that. But it really takes into account that I'm a bit different than, someone else. And my point here is that one size does not fit all, right? If you want to create a great product, you have to think that your users are a little bit different from each other. And you have to have a way, like a mental model to think about them. So, next time you buy a software, do you want a software that looks like this or a software that looks like this, right? So my point here is that there's a lot of value in segmenting a user base. So that's what I'm going to talk about for most of the talk. Just going to take a little sip because it's a long talk. All right. So this is our user base. Let's segment it. We can maybe, cut it into people with long hair on one side, short hair on the other side. Might make sense. Like, let's say that you're a shampoo company. That might make sense. But there's maybe, something like this, like people with glasses, people wearing hats. I'm not sure exactly what's the best way to segment all those users. And the point is that there is not a single right answer either. So I'm just going to walk you through a methodology that multiple people have used in my company, and it worked pretty well. So the purpose of our segmentation is to create a mental model for the product team to think about, entrepreneurs, because like our users at Shopify are entrepreneurs. And the idea would be to find 2 to 5 groups using a method that is called clustering. And why 2 to 5? It's because we want to create this mental model. So if we have 150, like the meetings with the product managers will never end, right? So you want to have like something that people can have in their head at all times. Those groups need to be big enough. What I mean is that like we don't care that much about the 20 people in a corner if we have like 500,000 people here. So they must be big enough to make sense, but also, you know, small enough to bring some color to the way that we want to understand our users. And the most important point is actually they need to be interpretable, because, you know, you can throw as many features and as many, you know, clustering algorithms you want at your data, but the end goal is really to have this mental model. So if it's not interpretable, you really miss the mark. And we'll see that it's actually a very important part of the process. And also, as Tristan talked before, the workflow is real, but the data is fake. So the tool I will be using for this is called Jupyter Notebook. I really love it. If you've never used it before, check it out. It is in your browser, and you can have Markdown to do some text editing, take notes. It's great if you're a scientist, because then you have like all your methodology along with your code, which is super great. You have your code, and when you execute it, the output is printed right below. So you have everything in one, and it's called a notebook, so check it out. So step 0, because you know, it's the first step in Python. We start counting at 0. Brainstorm features with your colleagues. And that's super important, because garbage in, garbage out. And what are the features? So let's say that I want to segment my user base. I will talk, say, with a designer and ask them, you know, what's on your mind about your product? And maybe they will say something like, I don't know. I don't know if I should put this element up or here, or if this thing should be drag and drop, or if people are okay with writing code, or you know, if we should make it easier to add different variants to this product page and things like that. So so cool, you've talked to one designer. Maybe talk also to product managers, because they have, well, they will be your clients at the end, so they have also pretty strong opinions on that. If you have UX researchers in your organization, UX researchers are a great source of information, especially because they have anecdotes from talking to a lot of merchants. They've done interviews, they've done surveys. They maybe already have, you know, a ton of CSV files that are not even in your database that you can reuse. And they have a lot of empathy for the user, so they're a really great source. But if you're in a small company and you don't necessarily have UX researchers, talk with the people in the customer support. They talk with with the end users the most, and they have a really good idea of what is easy to do, what is not easy to do, and the different types of people that they interact with. So, you know, at this stage of a project, the risk is all the unknowns. So by talking with people, this is how like you figure out those unknowns, and then you get, well, they become knowns, basically. Then step 1, get data from multiple sources. As I said, you might have already survey data floating around in a CSV file, and you might have a colleague that has already did an ETL job that would dump a very nice data set in the front room in a database. But you might also have, you know, petabytes of data on HDFS, and you want to exploit that. So once you have your grocery list of features, you can go in and put them all together. So just import pandas, and at Shopify we have something that's called Starscream, which is basically our ETL pipelines. So the read method will just help me read a folder on HDFS to have it as a PySpark data frame. So cool, with pandas I can read from a CSV. So this is where I got my survey data. We have this very cool thing that the data engineers made. So it's a Python command that you can pass a string that is SQL, and it will return the pandas data frame, which is super useful. And you can you know, use the read method, get the PySpark data frame, then do your heavy manipulation. So here, say I'm grouping by, say, shop ID. This might be, you know, the data itself might be too big to fit in memory, but since it's in PySpark, my cluster will, take care of it, aggregate, and then return it to me in a pandas data frame as well, and then I can join everything together. So, like a few years ago, this was not possible where I work. But now we have all this cool tooling, so in a few lines of code, I have all the data I want in one big data set, in this case, a pandas data frame. So my step 2 would be just the basic cleaning, removing rows. So maybe in my survey, the survey was localized, so I just want to keep the rows of the users that answered in English. I want to remove some columns. So for instance, like a lot of questions are, other please specify. I don't necessarily want those for my clustering. So I will just remove them. And most importantly, dealing with missing values. This is where you need to use your judgment. But in my case, I just replace the missing values with did not answer, because this is what happens in my survey. But maybe in your application, it would mean that it would be okay to say replace all the not a number by a 0, for instance. Or maybe it's not okay, and you should really remove those rows. So you have to know your data, to know what is appropriate to do here. But in my case, I just replace it with did not answer. Step 3, do more feature engineering, because now you have your feature that were given to you basically by your database. But a lot of times, a good feature might be an interaction between two other features. So for instance, well, I talked about variants in products. So let's say my product is a cardigan like this, and the variants might be 5 different sizes and 5 different colors, so I have 25 different variants. Versus someone that sells something else, maybe microphones, and there's only one of this kind, or maybe 2 because you have different voltages or something like that. So maybe the needs of those of people who sell a lot of variants is different because the product complexity is not the same. So maybe that's an hypothesis that I have, and maybe I want to have this feature in my data set. Well, it's pretty easy. You just add it. So I find that a ratio, say, of variants to products would be an interesting feature to have. So that's something you can keep in mind. Think about what are the features that would be interesting to have as ratios. Other ideas, bucketing, especially if you have categorical data, you can put them into buckets. That's what I call bucketing. Differences, especially with time, a bit like what Tristan said a bit before. Maybe you're not that much interested in the date that people started something and they stopped doing something or did something else. Maybe you're interested in the duration between those two events. So think about differences. And I put logarithm in there because sometimes things just scale logarithmically. So for instance, I don't know, some physical things like the power of sound or other things like that, or the perception of sound is logarithmic, so you might want to, if you have just like the acoustic pressure, you might want to take the logarithm of that instead, or things like that. Cool. Then now that we have all this data, you have all kinds of numbers in there, and some of those numbers might be really big and others really small. So if you want your clustering algorithm to work, you need to put everything in in a nice range. So one of the first thing I like to do is if I have categorical data, so let's say, do you have a retail location? You have maybe 3 different answers. You can do one hot encoding that is also called dummy variables. So I think it depends on in which community you are. I don't know why, my colleagues call it one hot encoding, but in pandas it's actually called get dummies. But what it will do, it will create 3 different columns with ones and zeros depending on if the user had this attribute. So it's pretty cool because now I can give this to an algorithm because it's numbers, while in the first case it would not have worked. So you do that. And if you have other things like numbers that are not between 0 and 1, for instance, you want to scale them. So here I just have an example. So maybe you have the number of apps that the store installed, but instead of having the values between 5 and 15, you might want to have them between 0 and 1. And this is very useful that scikit-learn has a lot of different scalars. I like the min-max scalar because I like things to be between 0 and 1. But you might prefer another one depending on your application. And now, dimensionality reduction. If you've ever done machine learning, you've heard of this, the curse of dimensionality. I recently did some clustering on my survey data. I had something like 100 different dimensions. And when you are in high dimensions, your distance matrix, your Euclidean distance, start to lose sense because in 100 dimension, it's just like everything kind of looks the same. So you really have to reduce it to less dimensions. So something that is pretty that people do very often is using a PCA, principal component analysis. So here I've just plotted the number of components and cumulative explained variance. So that's what usually people look at. So basically what it shows is that you don't necessarily need to keep all of your features because you would get most of it right. But I kind of like to also dabble a little bit in this and see, like, in just two components, just 2 dimensions, can I get away with a pretty nice clustering? And then we'll use k-means for this. So if you've done some probably Coursera class, or if you use scikit-learn before, the very classic example is with the iris dataset. So that's maybe what you have in mind when you think about, let's cluster something. It looks like this. You have 3 classes that are pretty well separated from one another. Maybe not the 2 in the middle, but there's one that's pretty different. And you might apply, a couple different, how do you say, ways to look at how your clustering is good, such as the silhouette score or the Kalinski-Arabras score, or the sum of means inside your clusters, and it will all look good, and you will always have like the nice elbow or the nice peak for those things. But what I've seen in the wild looks more like this. People are on a really interesting spectrum of behaviors and of tastes and of personalities. You don't have, let's say, because otherwise you just have stereotypes, like big heavy metal guy and like little something, right? It doesn't work like that with people. You don't necessarily have big clusters. What you have is basically the spectrum, like this whole pie, and your goal here is just to slice it in the way that makes the most sense. But it doesn't mean that there is one way to slice the pie correctly. It doesn't mean that there is well-defined clusters. And that's why I've put this quote here, that the goal is that the objects in a group should be similar to one another and different from the objects in other groups. But in many application, clusters are not well separated from one another. So if you've never done machine learning and you thought that people that were doing it were super geniuses, they just know those 3 lines. So actually the hard part about machine learning is everything that I said before. It's like preparing the data and doing the feature engineering and how you're going to interpret it afterwards and all that kind of knowledge around it. But actually, like the implementation in Python, like if you're doing like simple stuff like k-means, it's really just that. Now I have my clusters. And so when I have my clusters, it kind of looks like this. So I have my, what hot encoded features. I only kept 3 because otherwise it wouldn't fit here. And the number of my cluster. And the number is pretty meaningless. It's just one of the colors that we've seen before. And that makes the interpretation part a really important part. So the way that I found it was working really well for us was to do something that my colleague calls indexing. So what we mean by that is that, remember like all my data, no, actually that's not true. Yes, okay, let me start that again. So if you take your cluster data and you group it by cluster, you can take the mean of that thing. And then you can subtract the mean and normalize. So basically, everything that will be at 0 will be, this is normal for my group. If you're closer to 1, you will be, over-indexing for that group. That means that your group is doing this thing more than the others. And if you're at -1, it means that your group is doing this thing less than the other groups. Depending on your application, like for me, this works really well because all my data is between 0 and 1, and I don't have like a lot of outliers. You can use the median instead. The idea is to find like what's your baseline. Is your baseline like the median for this thing or the mean? Then you put everyone there, and then you don't even have to put between people between 0 and 1. But I kind of like it because then you can. It's easier for me to interpret. But that's the main idea. And also something very, very cool that I learned recently is that you can apply styles to your data frames, which makes my life much easier. So here I'm just saying, okay, if the value is smaller than 0.5, minus 0.5, it will be red. Otherwise, if it's larger than 0.5, it would be green, and this will just make my life a bit easier when I try to interpret my data. And it looks like this. When I do it, I usually have, maybe 100 different features. So this is really cool because now I can see at a glance that, say, cluster 1 is a cluster of merchants who would use it's a full-time business. They have a physical store, so that means they are a retailer. They had business experience before, and they have at least 1 employee. So, like, to me, this looks like really like my, I have this image in my head of like my neighborhood retailer that have, their physical store. Well, if I look at cluster 0, their business is not full-time, so they're part-time. They don't have a physical store. And they do have an online store, so they're online only. They are using social media channels, and they don't really have a business experience before, and they don't have an employee. So that looks like me more like someone that has maybe, a hobby that they want to turn into profit using an online store or something like that. So what I will do, I would look at something like this and take notes and try to draw a picture around that. And if it's something that totally makes sense, then I will go back and talk about it with my coworkers. If it totally doesn't make sense, I go back and rethink about my features. Yeah. And step 9, oh, did I skip a step? Darn. Tell people, because when you're, when you're in a role where you're doing research, you know, you could have done all that research and never tell anyone, but then nothing will change. That's not how you have impact. You know, you can't just write on your CV, oh, I've done like 10 clustering things, if you've never presented it to someone and it actually changed the way the business works. So I find that as a data scientist, you really need to get out of your introverted self and get out there and talk to people and really make a change in your organization or whatever project you're doing by communicating that data. And sometimes communicating that data means you're showing a pie chart. I hope you're not using pie charts, but if that works for influencing people, do it. Like in our case, this is actually, well, I've blurred the sensitive parts, but we can make kind of a persona card like this to, so next time I talk with say a product manager, I could say like, oh, like the way that your product will impact brick and mortar business, and this is what we mean by a brick and mortar business. It's people that have their main focus is their in-store experience. They're not really worrying about their online store, what they need to succeed, what they struggle with, what are their goals, and some maybe key metrics at the top that we've blurred there. But that's just one way to present them. But so far, it works pretty well to do it that way. Also, I would say if you have a channel in your company to do talks, either like, I don't know, a Friday with a beer, get in front of everyone and present them this kind of thing, or just book a meeting with the appropriate people, but you need to get the word out. So in conclusion, doing this kind of segmentation uses a great deal of domain knowledge, so that's why we talk to everyone in the first place, and also some pretty darn cool data science skills. But also something that is, maybe I haven't said explicitly so far, but you've probably sensed it with all the cool tools that I use, is that I'm empowered to do this kind of work with this scale of data, because I work with a team of data engineers. For instance, like my IPython notebook, Jupyter notebook runs on a cluster that is maintained by someone else, which is amazing because in my previous job I was I was maintaining my own cluster, and that was like a lot of time when things go wrong. So I really like to have a team and people to lean on to take care of that kind of problems or that kind of challenges. And also they create like those awesome tools like the Presto query that I can use to query the database. So that's it for me. Thank you.